All right now. Now, when we talk about laws of indices, we have what we call, when we have law of indices, we have law 1. If we have a raised to power n times a raised to power n. Now, look at all these numbers. All these numbers, we have a and we have a here. Now, whenever you multiply a and a together, and then they have different powers, you take one of these a, take one of the two a's like that, like the base like that, you take it and then you add the powers. That is n plus n. That's it. So now you can have 2 raised to power 3 times 2 raised to power 2. Now, because they have the same base, then you say 2 raised to power 3 plus 2, which is equal to 2 raised to power 5. That's it. So now we have 2 raised to power 3 times 2 raised to power 2. That means that you take 2 raised to power 3 plus 2, which is 2 raised to power 5. Another person can decide that the way I want to solve it, 2 raised to power 5 is 32. Another person will say 2 raised to power 3 is 2 times 2 times 2. And then 2 raised to power 2 is times 2 times 2. Now 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 32. It's still the same thing. So now you can log 2 now. Log 2. If you have a raised to power n divided by a raised to power n divided by a raised to power n. The other time when we deal with multiplication, we are dealing with addition. Multiplication is always going in line with addition. But here we have division. Division will always be going in line with subtraction. So now, whenever you have a raised to power m divided by a raised to power n, this one will be equal to a raised to power m minus n. A raised to power m minus n. Take note of that. So try and take note of that. If it is divided by or division sign, division is always going in line with what? Subtraction. That is it. So now, peradventure you are given a question like 2 raised to power 3 divided by 2 raised to power 2. You can have it like that, or you have it like 2 raised to power 3 all over 2 raised to power 2. Now look at this. Take one of the two, then you subtract the power 3 minus 2, which is equal to 2 raised to power 1. That is it. So 2 raised to power 3 minus 2, that is 2 raised to power 1, which is equal to 2. And some people will decide that this is how I want to do it. 2 raised to power 3 all over 2 raised to power 2, which will be equal to 2 times 2 times 2 all over 2 raised to power 2 is 2 times 2. 2 times 2 is 4. 4 times 2 is 8. That is 8 all over 2 times 2, that's 4. That's 8 all over 2. 8 over 2 is equal to 2. So simple, like that. So now the next thing is, anytime we have number 3 log 3, anytime we have a raised to power 0, let's start with that. A raised to power 0, anything raised to power 0 is equal to 1. Anything whatsoever raised to power 0, Oprald raised to power 0 is equal to 1. Anything whatsoever raised to power 0 is equal to 1. You can have 2 raised to power 0, that is 1. You can have 100 raised to power 0, which is equal to 1. Raised to power minus 1, this is number 4. A raised to power minus 1. Anytime you have a raised to power minus 1, this is equal to 1 all over a. Now why? Anytime you have something like negative power, that negative power means 1 all over what you are dealing with, a. So now, if you have a raised to power minus n, a raised to power minus n is equal to 1 all over, that minus means 1 over a raised to power n. 1 all over a raised to power n. That is it. That is it. So now, tomorrow they can give you question like a raised to power minus 2. I told you minus is 1 all over. Write this a. What is the power we have here? Square. That's 2. Please, are we communicating? That is it. So simple. We have a raised to power minus 2. That is equal to 1 all over a raised to power 2. So now, peradventure we have a question like a raised to power minus 3. A raised to power minus 3 is 1 all over a raised to power 3. That is it. So now, anytime you have minus is 1 all over a raised to the power 3 to the power n. Alright, this is number 5. Number 5, yes. A raised to the power m or raised to the power n. This can be equal to a raised to the power nn. Or you call it a raised to the power n or raised to the power m. When we start solving question, I will show you the application of all these laws. I will show you the application. But here from now, peradventure we have something like a raised to the power 2x. I can rewrite this one as a raised to the power x all squared. Or I write it as a raised to the power 2 all raised to the power x. That's it. So now, a raised to the power 2x can be equal to a raised to the power x all raised to the power 2 or a raised to the power 2 all raised to the power x. Peradventure we have 2 raised to the power 2x now. This can be equal to 2 raised to the power x all square, or you say that 2 raised to the power 2 all raised to the power x. That is it. So now we can have this thing as 2 raised to the power 2x or 2 raised to the power x all square or 2 raised to the power. So now try this. What if you have something like 5 raised to the power 2x? I'm so sure you should be able to try this. How will you do it? You will say this one is equal to 5 raised to the power 2 all raised to the power x, or you say 5 raised to the power x all raised to the power 2. That is it. That is so straightforward. I told you a raised to the power m all raised to the power n is equal to a raised to the power mn, and which is equal to a raised to the power n all raised to the power what? M. That one is so important. Now let's go to number 6. Number 6 is talking about a raised to the power m all over n. A raised to the power m all over n. I can rewrite this one as a raised to the power n times 1 all over n. That's it. I can write this thing like this. So now, a raised to the power m, everything raised to the power 1 over n. Anytime you have anything raised to the power 1 over n, this one is equal to nth roots of what you have inside the bracket, a raised to the power n. So now what am I trying to say? Anytime you have a raised to the power 1 all over n, this one is equal to nth root of a. Now let us now say that we have a raised to the power 1 all over 3. What will this one give us? That's cube root of a. Some students always make mistake when it comes to this. There is difference between cube root of a and 3 roots a. This one here is 3 times a, 3 times root a. That means that root a in 3 places. That's it. 3 times root a. That's it. 3 times root a. Now, but this one is cube root of what? Of a. That's cube root of a. That is so easy. Try and take note of that. This one is cube root of a, and this one is 3 roots a. Peradventure we have a question like cube root of 8. Let's say 3 roots 8, and we have cube root of 8. Let's look at this thing. Now from here, this one can be 3 roots 4 times 2, which will be equal to 3. Root 4 is times 2, root 2. But this one is equal to, anytime you have cube root of 8, here will be 6 root 2, and cube root of 8 is equal to, now, cube root of 2 raised to the power 3. So from here, we can say this one is, now we have 2 raised to the power 3. I can say 2 raised to the power 3, everything raised to the power 1 over 3. Now 3 cancel 3. Then we have this one to be equal to 2. Look at this. Cube root of 8 is equal to 3 root 2 raised to the power 3, which is 8. Now from here, 2 raised to the power 3 times 1 all over 3. Why is it 1 over 3? Because it's cube roots. Because it's cube root. So now 3 joins 1 all over 3. So 3 cancel 3. We have the answer to be 2. But for here, we have 3 roots 8. 3 roots 8 will be equal to 3 root 4 times 2. Now root 4 is 2. 3 times 2, that's 6. 6 root 2. You can see that they are two different things. Here is 6 root 2, and here it is 2. That is it. So now, try and take note of the difference between nth root of a and n roots a. They are two different things. Alright now, raised to the power x. we have a raised to power x is equal to b raised to power x, what will you do? Because they have the same power, your x will cancel x, then a will be equal to b. Anytime you have a raised to power x is equal to b raised to power x, because they carry the same power, then what will happen? X will cancel x, a will be equal to b. Peradventure we have something like 2 raised to power x is equal to 4. Look at this. From here, I can say that, or let me say, before I attempt this, let me say we have 2 raised to power, let's say x raised to power 2, good. X raised to power 2 is equal to 4. Now, let's look at this now. X raised to power 2 is equal to 4. I can say x raised to power 2 is equal to 2 raised to power 2. Now, they have the same powers. This power will cancel this power, then x will be equal to 2. X will be equal to 2. Because they have the same power, they must cancel out. Another one is, whenever you have a raised to power x is equal to a raised to power y. You know the other time, I was talking about the same powers and different bases. Now, the same powers and different bases. That was what I was talking about here. But here, it is the same basis but different power. The same thing will still happen. This thing will cancel this one. Then this one will be equal to this. X will be equal to y. So now, like the previous question I asked here, when we have 2 raised to power x is equal to 4. From here, I can say 2 raised to power x is equal to what? That is 2 raised to power what? 2. Now, this 2 is the same thing as this 2. 2 cancel 2. Then x will be equal to 2. X will be equal to 2. So simple, so easy like that. So now, tomorrow they can give you a question whereby they just say 2 raised to power x is equal to 8. And they are asking you to find x. What will you do? You say 2 raised to power x is equal to 2 raised to power 3. Now 2 cancel 2. X will be equal to 3. That's simple. X will be equal to what? X will be equal to 3. Good. Alright now. Now, after solving all these laws of indices, this one will now take us into questions and answer. How did WAEC always ask question on this part? WAEC, we want to look at how WAEC always ask question, how JAMB always ask question, how they always ask question on indices and logarithm. Now, let us start with this. Peradventure, we have a question like, simplify 7x squared times 2x raised to power 5. Everything all over 7x raised to power 6. Now look at this. We have 7x squared times 2x raised to power 5 all over 7x raised to power 6. What will this one be? Now, everybody, one thing you have to do is that you first multiply the numbers you are having. Multiply 7 times 2, what's that? That is 14. Okay? That is 14. Now, you have x raised to power 2 here, and you have x raised to power 5 here. What will you do to this question? Because they are the same x. I told you they are the same base. You take one of the two bases. Now, take one of the two bases. Take one of these two, you have x. And then, because it is multiplication between them, you will add the powers. That is 2 plus 5. Everything all over 7x raised to power 6. So from here, we have this to be equal to 14x raised to power 7 all over 7x raised to power 6. Now, what is 14 divided by 7? That is 2. Now, take one of the, you know that I told you, anytime you have divided by division sign, one thing you will do is that you will what? You will subtract the powers. Now from here, we can say this is 2x raised to power 7 minus 6. Why is this 7 minus 6? Because there is division sign between them. Then you subtract the powers. So from here, we have this one to be equal to 2x raised to power 7 minus 6. That is 1. So the answer is what? 2x. Let me come back again. 7x raised to power 2 times 2x raised to power 5 all over 7x raised to power 6. So people can decide to solve it like this. Another person can say upright. I will say this 7x squared all over 7x squared. Well, that one will be a long method. So now what you just need to do is that multiply 7 times 2. That is what? That is 14. We have x squared here. We have x raised to the power 5 here. Bring one of the two x. Bring it here. Then you do what? You add the powers. That's 2 plus 5. Which is 14x raised to the power 7 all over 7x raised to the power 6. So from here, we have 14 divided by 7, that is 2. Now we have x raised to the power 7 divided by x raised to the power 6. Take one of the x. Then what will you do to the power? You subtract the power. Hello, whenever you are multiplying two values together, two bases together that carry power, you are multiplying those two bases together, and those two bases are the same thing. Look at it, the same thing like that. The same thing. What you will do is to add the powers. But then, when you are dividing them together, what you will do to those powers is to do what? You subtract the powers. This is the question. The question is 8x raised to the power minus 2 is equal to 2 all over 25. I'm so sure some of you are so familiar with this question because some people have tried JAMB several times, and then you are finding problem with solving question on this aspect. Now, I will teach you how to attempt question like this. Now from here, you can see this one is 8 dots. I told you that anytime you have x raised to the power minus 2, x raised to the power minus 2, that minus making 1 all over, this one will be s squared. Now, past the year I've been taking questions on mathematics, I've been solving questions. Some people always ask the question that, Oprald, why is it that this minus 2 doesn't affect this 8? That's the question they always ask. And then some of you are there, you are looking at me and you want to ask me that kind of question. Oh yeah, let me go about this. From here, look at this. There is difference between 8x raised to the power minus 2 and 8x, everything raised to the power minus 2. Now, this minus 2 here belong to only x. But here, minus 2 here belong to 8 and x. So anytime you have it like this, then you will know that that minus 2 will affect what? 8 and x. But here, this minus 2 will only affect x. So try and take that so serious. Try and take that so serious. I think I explained that now. Alright? So now, I say my x. This minus 2 is just for this x alone. That's the reason why I told you this minus will be 1 all over s squared. Alright? Which is equal to 2 all over 25. 8 times 1, that is 8 all over s squared. What will this one be? That is 2 all over 25. Now, cross multiply. When you cross multiply, we have 2s squared. Cross multiply, we have 2 times s squared. 2s squared equals 8 times 25. That is 200. Now, the next thing to do is to divide all through by 2. Divide all through by 2. Divide all through by 2. So now we have this one to be what? S squared is equal to 100. Alright? From here, when s squared is equal to 100, then you say s squared is equal to what? 10 raised to the power 2. I told you something earlier when we are dealing with laws of indices. I said whenever you have a raised to the power x is equal to b raised to the power x, because they have the same power, you cancel out the power. So now they have the same power here. 2 we cancel 2. Then x is equal to 10. So simple.